Set up my transcripts. Okay. Boom. I think it's, yeah, there we go. Okay. For those of you who joined us late, real quick, quiz on Thursday, chapter 9 only. I'm going to spend a little bit of time at the start of class tonight, a little bit of time tomorrow night, reviewing some key ideas from chapter 9. Okay. If you have more questions, they could come out now or they could come out during office hours. That's from 6 to 6:30. Chapter 9 started with a study of complex numbers. Complex numbers use I, where I was defined as the square root. And remember, this is only the square root, not the cube root, not the fourth root. Only the square root of -1 is called I. Okay. And then we use that in all kinds of ways. All right. So the first one here, the first thing I said was the instant you see a negative inside of a square root, you pull it out and call it I. So that has to be your first step. Okay. The instant you see a negative inside of a square root, you pull it out and call it I. Instantly. Okay. Now then you study the rest of the problem and go, well, how do I do this? Okay. And it was very interesting to me to see how some of you guys multiplied binomials together on the exam. 3i radical 2, 3i radical 2. I mean, there was slightly different techniques. A lot of people got it right. We'll talk about it. But the way I've been doing it consistently in class is when I have to square something or multiply two binomials, I always put it in a matrix. Okay, so 3 times 3 is 9. 3 times I is 3i radical 2. I times 3 is 3i radical 2. And I times that is I squared radical 4. Because we're doing the outside, outside, inside, inside, which becomes -1 times 2, which becomes -2. Okay, so now you look for like terms. 9 and -2 is 7. And 3i and 3i radical 2 is 6i radical 2. And that's your answer. And remember, we try to put the real number in front and the imaginary number at the back end of a complex number. Complex number, the first number is just the pure real. The second number has the I in it. So anyway, that's the answer for number 1. Any questions? Okay, I want to jump to number 3. I said number 2 is going to be weird. It is. What are the things that i's can't have? You can't have an I in the denominator. Just like you can't have a radical in the denominator. Okay, and that was what exam 2 was all about. So when you had a radical, you multiply top and bottom usually by that radical, and then things seem to work out. When you have an I, you multiply top and bottom by an I. If you have a single I, you multiply by I. So that gives you, excuse me, 7i over 2i squared. But I squared is worth -1. So this becomes 7i over -2. And that would be your final answer. So in my mind, I draw a lot of parallels between can't have a single radical in the denominator. So you multiply top and bottom by that radical, usually if it's a square root. You can't have an I in the denominator. So you multiply top and bottom by I. Okay, this one over here. A couple of people screwed up on the exam 2. We multiply by the conjugate. Almost everybody figured that one out, but they screwed up on a lot of people on what was the conjugate. the conjugate is going to be 6 plus 2i. Okay, really important that when you do the conjugate, if this was a minus, the conjugate has a plus. Or if this was a plus, the conjugate has a minus. Okay, really important that. And some people, when you get your test back on Thursday, you're going to kick yourself because you didn't use, you had the right idea, kind of, sort of, but you had the wrong number. You have to have a plus. If this has a minus, you have to use a plus. If this was a plus, you have to use a minus over there. And then do the same thing top and bottom. So distribute this mess together. 5 times 6 is 30 plus 10i. Okay. When you FOIL these or multiply these together on your scratch paper, okay, whatever, 6 minus 2i, 6 plus 2i, 6 minus 2i, 6 plus 2i, you come over here, you get 36 plus 12i, 6 times 2 is 12, minus 12i, negative 2 times 6 is negative 12i, and negative 2 times positive 2 is negative 4i squared. 2 times 2 is 4, I times I is I squared, but I squared is negative 1, so this is negative 4 times negative 1, so this is 4. So when you add like terms, you have 36 and 4 is 40, okay? And the minus 12i and the plus 12i cancel each other out. So this is 40. Now, there's a couple of things we can do here. This isn't quite done. That's the hard work. And maybe I should stop right there. Conjugate, distribute in the top, use my matrix for the denominator. I get here. I'm not done, but does anybody have any questions as to how I got here? Okay. Can this be reduced?
Yes.
By how much?
You can divide it by 10.
10, yeah. So you can take the top and divide it by 10, and the bottom divide it by 10. Okay, they all 10 goes into all of them. So that gives you 3 plus 1i over 4. Again, you have to be able to divide everybody by that same number. Everybody has to divide by the same number, top and bottom. Now, one last thing is mathematicians get all pissy about it. Theoretically, we're supposed to separate this as 3 over 4 plus 1i over 4. Okay, I don't think I'll take, in fact, I know I won't take off. I'll circle it. I'll say something like should separate it or something, but I won't take off for that. So if you got this, I'd be delighted. This is better. Separated. Remember, we need to separate the real numbers separated from the complex. So we take this fraction apart. Okay. So we had to reduce it and then separate it if we can. All right. So that's problem 1, 3, and 4. Any questions about my steps up here before I go back and show you number 2? You're sure? Okay. Then I need to erase some of this. Can I erase this number 1 over here for from everybody? Okay, I'm waiting for somebody to yell. Nobody is. Okay. Don't take notes yet. What I'm going to show you is developing a rule. Once I get there, then I'll tell you when to start taking notes. Okay, So don't waste your time unless you want to. But we know that any number to the first power is itself. I to the first power is I. We also know, we've been using this all over the place, that I to the second power is -1. Okay, those, you got to know that one. Now, the question is, what is I to the third power? Well, over on my scratch paper, if I take I to the third power, I could separate it as I to the second times I, which becomes -1 times I, which becomes -I. So I to the third, take it apart a little bit. Notice I took it apart to take advantage of I to the second. I to the second becomes -1. -1 times I is -I. So I to the third is -I. Okay. Then what's I to the fourth? Well, you sit there and think a minute. I to the fourth. Oh, that could be I to the second times I to the second, using my rules of exponents. But I to the second is -1 times another -1. -1 times -1 is +1. So I to the fourth is +1. I want to draw a little line there because important things are going to happen. So I'm going to keep doing this. I'm going to keep taking powers of I, and I'm going to figure them out by breaking them down and using, prior defined or prior calculated values. For example, I to the fifth. Well, okay, let's look at I to the fifth. I to the fifth is I to the fourth times I to the first. But I to the fourth, we just calculated is 1. I to the fourth is 1 times I is I. Uh-oh, wait a minute, this is weird. Look what's happening. I to the first is I. I to the fifth is I. Something weird is happening here. Let's try I to the sixth. I'm not in the, okay. I to the sixth could be I to the fourth times I to the second. Could be, okay. Well, but I to the fourth is 1, and I to the second is -1. So I to the sixth is 1 times -1, which is -1. I to the sixth is -1. Oh, wait a minute. We're following this pattern. I to the sixth is -1. I see a pattern here. I, -1, -I, +1. I, -1. Okay, let's guess. According to the pattern, I to the seventh should be -I. Well, is it? Okay. I to the seventh is I to the fourth. We always go back to I to the fourth because it was easy. I to the fourth becomes 1. So I always keep cycling back and using that times I to the third. Okay, so this is 1 for I to the fourth times -I. Whoops, -I, dummy, is -I. Oop, and it should have been -I, and I copied it wrong. I'm sorry. Okay. So there's a pattern here, and I'm not going to bother you with the math. I to the eighth becomes 1. Okay. This is a cyclic pattern, or some people call it a periodic pattern. In math, a period is when something repeats itself after a certain number of steps. Like we talk about the period of the moon, going from no moon to full moon, back to no moon, the month is 28 days. Okay. Some people call it a cycle, some people call it a period. But for the powers of I, the period is 4. Okay. And then it starts to repeat itself again. It's a periodic, it comes out in some kind of pattern that keeps following itself. So the question is, if I wanted to do I to the 44th power, I have 2 ways of doing it. First way is I could do this down to 44. And I've seen people do that on a test or quiz. Okay. The other way, now is when you want to start taking notes, guys. Okay. Key thing in your notes is the period for I to a power. This is the period equals 4. So what we're going to do is take 4 into 44. 4 into the power. Okay. You can use your calculator or whatever, but the important thing is the remainder. Remainder 0. Okay. Shoot. Should have started with that over here. Well, wait a minute. That means this problem reduces to I to the 0 power. Look, the remainder was 0. When you divide by 4 and use the remainder, okay, that becomes our new one. Okay, so this reduces what's anything to the 0 power? 1. So I to the 44th is 1. Let's try a better one. I don't know, to the 279 power. Take a second on your calculator or whatever, take 279 divided by 4. So when I did it, I got 69, remainder 3. Okay. If you did it on your calculator, or if you did it as a fraction on your calculator, pushing the FD, if you did 279 fraction 4, it would probably give you 69 3/4, or maybe 69.75. But you're supposed to know that 0.75 is 3/4. That's like an automatic. And that meant the remainder was 3. Well, okay, what's all that mean? It means this reduces down. This number, you'd go through this pattern 69 times. 69 times you'd go through this pattern. I to the 25, I to the 45, I to the 57. You'd go through this group of 4 69 times and still be left with I to the 3rd in the last grouping. Well, okay, what's I to the 3rd reduced to? Negative I. And that's your final answer. So it's an interesting exercise. Is it important? Not really, although it's a nice introduction to what we call periodic functions. And almost everything you do in trigonometry will be called a periodic function, because it it repeats itself. You'll learn about something called the sine function. And that's one period or one cycle of the sine function, but the sine function keeps going forever and ever and ever. And so you'll learn about one period or one cycle of the sine curve, and you'll learn about the period or the cycle of the cosine curve, and all these other curves that you're going to end up studying. And they're all periodic because they all start to repeat themselves after a certain distance or after a certain time period, if you will. So this is a nice introduction to that. Okay. Is it critically important that you know this? That you know to take I to the divide by 4 and use the remainder? No. One problem. That's it on the exam. Maybe one problem on the chapter 9 quiz. Okay,
Professor,
real
I
quick.
have a question about that. So the 44 times, like I'm sorry, I is 44 times power. Can we think it as like, because as we know, I the second power equally -1. Can we do just like I?
Sure. But and for that one, it would work out fine. You're saying if I to 44,
Yeah,
that would be I to the 2 to
and
the 22.
2 times, yes.
So that would be -1 to the 22 power.
That would
And
be the 1.
that'd be +1 because you know the rule about even powers and odd powers.
Yes.
Absolutely. Okay, that's perfect. Won't work there.
That might have a like. Let me see. That might have a remaining, maybe.
In general, okay, what you hit upon, this is a great, I'm really delighted that you saw that pattern. That's it. That's just awesome. In general, the safest way is to take the number, divide it by 4, use the remainder.
Okay.
That's the safest way. It's not the only way, just the safest way. It works always. Your technique works great sometimes, and then it falls apart other times. Okay. And I'm not saying you're wrong. I'm just saying my way works better always.
Okay.
Okay.
Yes.
Just for fun, you guys try this one. I always love this one. I to the this is the date 2021. So what's reduce I to the 2021, whatever it reduces to.
Got a quick question.
Yeah.
How does I to the 0 power equals 1?
Anything to the 0 power.
Oh, okay. Oh yeah.
Remember back in
you're
chapter 4.
Yeah. Okay.
Yeah, I started this and I forgot the 0 power. I forgot to remind you of that. But anything to the 0 power is always 1. So I got this is the year 2021, I to the 2021 power, divide 4 into that, you've got 505 remainder 1. You use the 1, I to the first power, boom, is I. And that's the answer. Is that okay with everybody? I think there's been a few questions on your mom homework on that. And like I said, I think there'll be 1 on the quiz, 1 on the exam. maybe. I don't remember. Okay, I need to erase this, put some other problems up. Okay, so complex numbers that we just got done covering are going to be on Thursday's quizzing. All right, the other major thing, I mean, there's going to be other stuff, but the major thing is going to be equations to solve. The other thing on the quiz, equations to solve. So let's try this one. Number 5, we're going to have 5 plus 2 parentheses 3x minus 1 squared equals 7. Number 6, it's going to be 2x squared equals x minus 7. And number 7 is going to be x squared minus 4x equals 10. So let's pause the video, give you guys some time to work on that. Okay. Number 5 is a special type of equation. You did not have to do it the way I'm going to show you, but the way I'm going to show you is quicker than if you did it any other way. This is what was called, because all of my x's are inside a quantity squared. All of the x's are being squared. That's not true for this problem, and it's not true for this problem. But because all of the x's are being squared, I can use what was called the square root property. Okay, so what we have to do is get this isolated, get this quantity all by its lonesome. Okay, to do that, I'm going to take 5 away from both sides. So I'm going to get 2 parentheses 3x minus 1 squared equals 2, because if I take 5 away from both sides, then I'm going to divide both sides by 2 and get 1. Okay, now I can square root both sides. You can only do the square root of both sides when you've got this quantity by itself, quantity squared by itself on one side of the equation or the other. So mathematically, what we do is we say, okay, I square root this side and I square root this side. Okay, square rooting is the only thing that cancels square powering, but you can only do it when you get this side by itself, quantity squared. All right, so what happens? This all cancels out. I get 3x minus 1 equals. Now, 2 things happen here. The square root of 1 is 1. That's nice for us. But also, you must remember that the instant you square root both sides, okay, like I did up here, you put a plus or minus on the number on the opposite side of x. Okay, square root both sides like that. Now, at this point, different people show this differently, but when I showed this to you originally, I said this now separates into 2 problems. 3x minus 1 equals positive 1, or 3x minus 1 equals negative 1. Okay, this separates into 2 separate problems. So add 1 to both sides. This is 3x equals 2. This is x equals 2 divided by 3. Add 1 to both sides here. This is 3x equals 0. Divided out, x equals 0. So this particular problem has 2 answers of 2/3 and 0.
Would you have to test that?
No.
Oh, okay.
Well, okay, there's two ways to answer that question. Should you? Yes. Okay. Well, do you usually have to? No, not at all. Okay, 99% of the time, no. The only time you need to test it is if you had the square root of a problem, okay, equals, I don't know, let's go 16. Okay. Notice, whoops, equals, let's go 4. Notice the difference. This is starting with a square root, okay, and you square both sides. But this is starting with a square, so you square root both sides. Okay? When you start with a square root, you should always test. Okay, when you start with a square root, you should always check your answer. Why? Because there are restrictions. Remember how we talked about even and odd indices, and the stuff inside can't be positive or it can't be negative and all that kind of crud. So there are restrictions. There are weird things that go on with square roots. Okay. So anyway, no, you don't have to check this one. Should you? Yeah, you should always plug numbers back in and see if it makes the problem true. But 99.9% of the time it will. All right, so that's one way. Now, could you have gone to your scratch paper and squared this out and multiplied by 2 and added 5 and subtracted 7 and then use the quad formula? Yeah, you could have. Okay, but this is faster. All right, let's do this one. I'm going to use the quad formula on this one. I don't believe it factors, but to use the quad formula, it must equal 0. That's so important. If you're going to use the quad formula, the quadratic formula that you have memorized. And by the way, when you come to class and you do a brain dump or something like that, man, that ought to be the first thing you dump on your paper is the proper quad formula. Okay, make sure you know how to do that. So there's the quad formula. We have A equals 2. B is -1. It's implied there in front of the X. And C is 7. So here we go. X is negative of -1, no negative B, plus or minus the square root of, whoops, B squared minus 4 times 2 times 7, all over 2 times 2. So X equals 1 plus or minus, this is going to be 1 minus 56 all over 4. -1 squared is 1. -1 squared is +1. Minus 4 times 2 times 7 is 56. So this is X is 1 plus or minus the square root of -55 over 4. And I'm right in the middle of the glare, but you can still see the -55. What do you do with a negative number inside of a square root? Pull it out, call it I. So this becomes X is 1 plus or minus I radical 55 all over 4. Should we separate it? Yeah. The proper answer is 1/4 plus or minus I radical 55 fourths. Okay, I'm going to erase that. We'll do that one up in a minute. So, number 6 was a quadratic formula problem. Man, you better know that quad formula. Inside out, left and right. Okay, drunken stupor. Okay. must equal 0 before you start. Must be in proper order before you start. List the A, B, and C numbers, and then plug them into the formula. This particular one had a negative number inside the square root, so we have to deal with it with an I. Take the negative out, call it an I. Okay, and then, like I said, we should split it, but I'd still give you full credit if you had this. Is that okay for number 6? Okay. I want to erase number 5 and put the problem up there that I had a second ago. So can I erase number 5, the square root property, or does anybody have a question on it? Okay. So the problem that I deleted was number 7, which was x squared minus 4x equals 10. That one again, you're going to make it equal 0. You can talk about your quad formula. A is 1, B is -4, C is -10. So x equals negative of -4, negative of the B, plus or minus the square root of -4 squared minus 4 times 1 times -10, all divided by 2 times 1. So negative is +4, plus or minus somebody divided by 2. Okay. So 4 squared is 16 minus -40. Minus is plus, so this is 56. Okay. Again, if I'm doing a lot of my arithmetic now in my head, okay, if you want me to explain how I got 56 inside, cool, I can do that in a minute. Okay, but wait a minute, what happens to 56? Doesn't it simplify? Don't you always have to worry about, does my square root simplify? Okay, I think it does, doesn't it? Did this afternoon. So yes, it becomes 2 radical 14. So x is 4 plus or minus 2 radical 14, all divided by 2. Now comes the drudgery. Is that my final answer? No, because I can simplify, I can reduce everybody by 2. Okay. I need more room, so I need to erase. Okay. So if I divide, I get x is 2 plus or minus 1 radical 14 over 1. I don't need the ones anymore, so this is 2 plus or minus the square root of 14. And we're not going to be done with this problem. You're done now. Technically, you're done. But what if I said I wanted my answer rounded to the nearest hundredth? Okay, because we're going to be doing several word problems. okay, in both chapter 9 and 10 that have you go through all this stuff and then round your answer. Okay, for a little bit of historical or a little bit of fact, this is called the exact answer. Okay, we don't know what the square root of 14 is. The minute you put it into your calculator, the calculator rounds it off. Even it puts all these decimals here, the decimals go forever. So your calculator has truncated them, has chopped off the square root of 14. Okay, so if you leave it this way, it's called the exact answer. If you start using your calculator, that's called the approximate or the rounded answer. Now, we talked last week about how to use your calculator. 2 plus the square root of 14 is one of your answers, and 2 minus the square root of 14 is another. See if you can get the decimal equivalent of those. And so I got 5.7416. It goes on. Negative 1.7416. So if we round to the hundredth, is 5.74. We round to the hundredth, negative 1.74. Remember, hundredth means 2 decimal places. There's 2 zeros, hundredth, so there's 2 decimal places. That's the easy way to tell how to round. And these would either be called your approximate answers. Come on, where's my pen? I'm writing right in the glare. Okay, these are approximate, or these are the rounded answers. And a lot of the problems on MOM will ask you for the exact, and some will ask you for the approximate. Approximate means put all this crud into your calculator. Exact means don't. Just leave it there. Okay. Questions about anything I've talked about tonight? Complex numbers, imaginary, rationalize the denominator with the I or the conjugate of I, the square root principle, the quadratic formula, and the difference between exact versus approximate. Any questions? Okay. Then, excuse me, I would like to do one problem from that worksheet that we did last week. One more, because I didn't get to a Pythagorean theorem problem. I don't think, did I or not? I don't remember. I wanted to do number 4. Did I do number 4 last week or not? Does anybody know? Is anybody awake? Nobody knows? Okay, well, I'll do it again. It'll be good exercise. I might finally learn how to do these. All right. So that was a chapter 9 review. Tomorrow night, I will do a little bit shorter chapter 9 stuff. Not too much because I've covered most of it. And then Thursday, when we come to class, we're going to do more chapter 10 and again around 8:15 or so, we'll stop and we'll take a chapter 9 quiz. Okay, so this should have, oh, I know what I wanted to tell you. I said this in the email. The quiz that I wrote for this Thursday. What I did is I looked at the mom quiz in chapter 9. It's practice quiz. It's open for you to go through and try. And I didn't take all of the problems. Okay. I did not take all of the problems. I took 10 or 11 of them instead of, I think there's like 15 or 16 there, but I chopped them down, made it a little bit shorter. Okay. But I took almost exactly word for word the problems from the mom, from the practice quiz in mom. So if you want to know what's going to be on chapter 9 quiz, go look at chapter 9 practice quiz in mom. Okay. And mine will be simpler than that. All right, I want to do one word problem and then jump into chapter 10. Yay, one word problem. I'm going to do number 4 from that handout I gave you, unless somebody can tell me I already did it. Okay. Number 4 says the hypotenuse is 2 more than twice the shortest leg. Okay. So if I set up a drawing here and I say X is the short leg. Somebody, remember, somebody's got to be X. Okay. So the hypotenuse is 2 more than, oops, I'm copying the wrong one. 3 times, I'm sorry, 3 times the shortest leg. Sorry, I didn't look at it correctly. 2 more than 3 times the shortest leg. Okay, so this would be 3 times the shortest leg plus 2. This is the hypotenuse. 3x plus 2. Okay, because of that phrase. Then it says the second leg is 7 more than short leg. Well, here's the other leg, and it's 7 more than the short leg, so it's x plus 7. So that's the first step, is taking the words, the hypotenuse equals, is equals, 2 more than means plus, okay? More than means add 2. 3 times means 3 times the short leg, which was x. That's how we translated it. So that's how I got the hypotenuse here. It said the second leg is, remember, is your equal sign. Second leg equals 7 more than, so that's plus 7, the short leg. 7 more than the short leg. All right, that's translating from English to math. And for a lot of people, that's the hardest thing. Is that okay? All right. Then we now apply Pythagoras. The Pythagorean theorem, or formula, was leg squared plus leg squared equals hypotenuse squared. So we have x squared plus x plus 7 quantity squared equals 3x plus 2 quantity squared. Okay, I need your attention. So those of you who were nodding off, please wake up. I saw people do this on exam 2 and it absolutely killed you. Okay, well, x squared was x squared, fine, whatever. Plus, this was written as x squared plus 49. When you have x plus 7, oops, squared, there's one person showed me they knew the shortcut, but in general, there is no shortcut. X plus 7 squared means x plus 7 times x plus 7, and you have to go through some way of multiplying them out. The matrix or foiling, you get x squared, 7x, 7x, 49. So the proper answer here, when you have x plus 7 squared, is x squared plus 14x plus 49. But by multiplying that wrong, you just ruined the whole rest of the problem. Okay? And that's chapter 5 stuff. That's fundamental, 5 and 6. Actually, it's chapter 6. Squaring a binomial. Okay? There is a formula you can use. One person showed me they knew the formula. Everybody else should have done something like this. 3x plus 2 quantity squared. Okay, if you multiply it out or set it as a matrix, should be 9x squared plus 12x plus 4. If you're not sure where that came from, ask me. I will be happy to show you. I set up something like this and multiplied it out. Okay, again, if you just said it was 9x squared plus 4, you ruined the whole problem. And that meant everything you did here was wasted. All right, so what do I have? I have 2x squared plus 14x plus 49, if I add like terms, equals 9x squared plus 12x plus 4. All right, now's where you got to make a decision. You've got to think, okay? It's a power of 2, okay? I have to make it equal 0. That's the only way to solve a power of 2. Well, that was a lie. There's a trick way, but if you're going to use factoring, if you're going to use the quad formula, it must equal 0. Now, I personally like my x squared number to be positive. And that's just a hang up on my part. So I would take 2x squared away from both sides and get 7x squared. I would take 14x away from both sides and get minus 2x. And I would take 49 away from both sides and get negative 45, and it would equal 0. I personally like my coefficient of the x squared to be a positive. If you took everything over here, you'd have a negative 7x squared. It would all work out the same. Just history has shown that I and most students make fewer mistakes when the coefficient of the x squared is a positive number. So anyway, I had to multiply that out, set it equals 0. Here I go. Yay. So here I have my A is 7, my B is -1, and my C is -45. Oh, thank God for calculators. So X is -1 plus or minus square root -4 times 7 all divided by 2 times 7.
Hey, Professor, shouldn't it be -2? Because you're taking away, was it -14 and +12? And you have, yeah.
Oh,
so
what
yes.
did
Yes.
I have B is Ted? What am I doing? Yes, you're right. -2. Thank you. Thank you. I have no idea where I was looking, but I was looking in the wrong place. You're right. Okay. This problem on the test, or if it shows up on Thursday's quiz, would ask you to use your calculator and round. Okay, I would not want anybody to waste time trying to simplify, the square root of whatever the hell that is. We'll figure it out in a minute. But this problem will say round your answer to the nearest tenth or whatever it is. Okay, it doesn't say it on the handout. It will say that on the quiz. So what do I have here? X is 2 plus or minus square root of somebody over 14. So that's going to be 4. Turn around. Clear it. 4, 7 times. Plus 4. 1264. Okay. Again, at this point, I wouldn't make my worst enemy try and simplify that. I just say now, go to your calculator. Okay. And here's the way I personally would do it. Okay. You can develop your own technique. On your calculator, go 2 plus square root of 1264. Okay. And hit the FD key. And what do we get? Two plus square root. Oh, it just automatically went to 37 point whatever. Did you guys get that or not? My calculator just automatically went to 37.55 something or other. Can anybody confirm?
Yeah, I got that answer.
Okay. But what have I left out of that? I've left out the 14. So I want to divide that by 14. So I let my calculator do the ugly work. Then I did divide it by 14. I know you young whippersnappers, okay, like to do it all on the calculator, one big giant step. And I found more people make mistakes when they try and do it all at one big step rather than cut it up in little steps. That's up to you, but just make sure we all get the same answer. So anyway, I get it as 2.6823. Okay, that's one of my X values. Okay, the other X value is if I went to minus the square root of 1264. So let's do that. Oops, I get -3.35527, whatever. I can stop here. Why? Why do I not have to do any more work?
The answer can't be negative.
Right, on a triangle, on something, X is the length of the shorter leg. Well, you can't have a negative length, whatever you do. Even when you divide by 14, it's still going to be negative. So this whole thing here is rejected. So the short leg, let's just round this, the short leg is 2.68. Again, I will tell you, or mom will tell you where to round. I will be very specific. Round to the nearest 10th or 100th or whatever I said. Okay. But that one was rejected. I don't know what else it said on number 4. Oh, all the sides, fine. I don't care about them. The answer should be on the back thing. But I was real concerned about you guys forgetting how to use the Pythagorean formula. When I said the back thing, the answers on this handout I gave you are on the back, I believe, for all of that. So you can double check my work and see everything. But Pythagoras is one that comes up over and over and over again. Okay, so make sure you know how to do that. Make sure you know how to use your calculator to get decimal values, okay, as well as exact values. Okay, I would like to stop all of this and get into chapter 10 and see how far we can get. It's a little bit early, but do you guys want to take like a 5-minute break right now, and then we won't have to break up chapter 10? Let's take a 5-minute break right now. I'm going to go find out where my wife went. She got in the car and drove off. Was it something I said? I don't know. We'll find out. But let's take a 5-minute break right now. Unfortunately, it's the most challenging chapter in our whole semester. It really is. And it should be chopped into 2 chapters. It's not. Chapter 10 has 3 distinct parts. 4, actually. 1 is an introduction, is a review of functions. And then it goes to exponential equations. Then it goes to something called logarithmic equations and functions. And then it goes to word problems. And as the instructor, as someone who's been doing this for years and years and years, I understand how all of these are interrelated to each other. I doubt sincerely that if this is your first time through this course, okay, you understand the interconnection between these. I'm going to try and help you to understand, okay? But you're just simply going to, you're going to just say, oh crap, I got to learn about functions. And then we learn about exponentials again. And then we learn about logarithmics. And it's going to be a lot of memorizing and a lot of note taking. And do not wait for the last minute to do your homework. Do your homework on time right away. Because if you get the slightest bit behind, if you don't ask questions of me or Lisi, okay, you're going to get lost in this chapter. So I need you to really pay attention, okay, and stay up with all of our work here. We're going to start with functions. Okay. Earlier this year, I defined a function as a math rule that changes the value of a number. Okay, so for example, I said if we had f of x equals, I don't know, like 2x minus 7, okay, then I ask you to find what is f of negative 2. Okay, and all you had to do was go 2 times negative 2 minus 7, work it out and get negative 15. No, negative 11. Nope. Okay, almost made another mistake tonight. So somehow negative 2 got changed into negative 11 according to this rule that we called f of x. Excuse me. Well, we're going to add to that. Not only is it a math rule that changes a number, okay, just like this, but also, and each x, and now x stands for the input number, or we call it the domain, matches with exactly one y value, which we call the output or the range. I will explain all of this. Okay. Our definition of a function is going to get more and more sophisticated as we go through chapter 10. Its basic idea is it's a math rule. Okay. But it's stronger than that. Okay. Here's an easy example, I think. So suppose this is some function. And I tell you that 2 got changed into 4, or excuse me, it's not a function. Erase that. This is some rule. 2 got changed into a 4. 5 got changed into a 7. And 3 got changed into a 4, according to some dumb rule. Somebody sat around one night, drank too many beers, came up with a rule, and they started plugging numbers in. And they plugged 2 in, and out came a 4. And they plugged 5 in, and out came a 7, and so on. And they plugged 3 in, and out came a 4. Okay. First question, is this a function? That's going to be a question on the chapter 10 exam. That's going to be a question in Mom. Does this represent a function? And the answer is yes, it does. Because you start at an x, and who does it match with? Only a 4. 5 matches with a 7. 3 matches with a 4. Okay. It's not that 2 numbers are go to 4. It's if I call out 2, how many numbers does it match with? Looking at the whole thing. 2 only matches with a single number. Okay. 3 only matches with a single number. The fact that these 2 match the same number doesn't matter. It's a matter of, think of this as, well, I was going to try and do an example about being in church. Okay. And somebody calls out, well, never mind. I'm not going to do that. Okay. So it's, if I call out 2, everybody will answer 4. 2 matches with 4. However, let's look at this one, a new rule. 3, 9, 7, 1, 3, 5. So here's another rule. Again, somebody was up late at night drinking a bunch of beers or whatever like that, and they came up with some crazy f of x like this. I don't know what it is. And 3, put it in, came out as a 9. 7, put it in, came out as a 1. 3, put it in, came out as a 5. Okay, is this a function? No, not a function. No. Why? Because 3 matches with 9 and it matches with 5. And the rule says each x, each starting number, 3, can match with only one y value, exactly one output number or y value. And here this is saying, nope, sometimes 3 goes to 9 and sometimes 3 goes to 5. Can't have that. So this is not a function. Okay. I've got some other examples, but I need to erase the board. Are we okay? Kind of. Does anybody have need clarification? This is the easiest way to see this concept is, well, actually, maybe another way is to see it and ask, does each x match with just one y value? And in this case, each x value, 2, 5, and 3, matches with only one y value. But in this case, 3 sometimes matches with 9, 3 sometimes matches with 5. It's not a function. Okay. There is another way to show this. Okay. If I gave us a graph, okay, let's take a nice, pretty big fat graph like that. Is this a function? Now, there's 2 ways to tell. And we've talked about actually both ways, but there's 2 ways. If you pick an x, like here, x, and read up to the graph, over to the y, it only matches once. Okay, this x sub 1 goes up, matches once, it's got one y value. Okay, pick another x. Okay, let's pick this one. Let's call this x sub 2. Read to the graph, move back over. It only matches with y sub 2. It matches with one answer. So each x that you pick matches with one y. Remember, a graph is made up of ordered pairs. Long time ago, when we were graphing straight lines, we said a graph is just a whole bunch of dots, ordered pairs. And I just picked 2 of them at random here. Okay, x goes here to here, that's its y value. X number 2 goes from here to here, that's its y value. Every x matches with one y value. The other thing I said was there's something we call the vertical line test. Okay, if you took a vertical line and pass it over the graph, how many points on the graph does it hit at any instant? Okay, it only hits 1 point on the graph at each instant. That's called the vertical line test. 1 point. Okay, and because of that, this is a function. Yes, function. But let's take a sideways parabola. Okay. And let's pick an X value. Here's X sub 1. I'm just picking a number at random. Here's X sub 1. Read to the graph. If I read up here, I get a Y sub 1. But why don't I read down to here and get a different Y sub 1? So this 1X, if I go to the graph, back to the Y-axis, to the graph, back to the Y-axis, this 1X has two different Y values associated with it, a positive and a negative one. Okay, two different Y values. Same thing, well, with anything here, if we take this X, if I take this X, different X, read to the graph. It's got a Y value here, but read to the graph, it's got a Y value here. So the black X has two different Y values. But the rule says each X can only have one Y value that's associated with it. The other thing is if you take your vertical line and pass it over the parabola or the curve, it hits more than one point at any instant. It hits a bunch of points, a point at the top and a point down below. Because of that, because it fails the vertical line test, fails that, we say this is not a function. Not function. So what you're going to see in, oh, you're going to see a couple things. In MOM, when you start the chapter 10.1, that's what we're in right now, homework, there's more, okay, is they may give you a list of ordered pairs, 2, 7, -3, 9, 4, 5. And they may say, does this represent a function? And you have to say, okay, does each X2 match with only one Y value? 7. Yeah. -3, 9. Yeah, one Y value, 4, 5. So this is a function. Okay. Mom may also give you a picture. If she gives you a picture, then you can use the vertical line test. If the vertical line hits only one point at a time, it's a function. But if the vertical line hits more than one point at a time, it's not a function. Okay? There's a little bit more to it than that, but that's a beginning. So that's the first idea. What is a function? It's a math rule that changes the value of a number by plugging it in. But it also has to follow this rule too, where each number you plug in to has only one answer. 7, 4, plug in. 5 is the answer. That's number one. Okay. And you're going to have to try some stuff in MOM and then come back and yell and scream and say, I don't get it. Okay. But you're going to have to try that. All right. Next thing. That was a function. Somebody is or isn't a function. The next thing in 10.1 is they do something called function composition. So function, it's a rule and it matches X with Y and so on. Okay, that's what we just kind of discussed. We'll do tomorrow, we'll extend this. But then there's something called function composition. And that's where you put one function into another function. All right, what's it look like? Let's take a simple case. Let's take f of x is 2x plus 7. And let's take g of x is x minus 4. I just made two new functions, just made them up. Two functions. Okay. Now, what if I said, here's our first problem. What is f of g of 2? Well, this is an example of function composition. We're going to put 2 into the g function, and we're going to put that answer into the f function. We always start on the inside and work out. Okay. But here, the g function is going to be put inside the f function. So f of g of 2, we start on the inside. Take 2, put it into the g function. G of 2 is 2 minus 4, which is negative 2. So what's that? What happens? G of 2 gets replaced with negative 2. And now my problem becomes f of negative 2. Because g of 2, I plugged in 2 into the g function, did my math, I get negative 2. Now I'm finding f of negative 2. What am I going to do? I'm going to plug negative 2 into the f function. Okay, so that means I'm going to go f of negative 2 is 2 times negative 2 plus 7. Negative 4 plus 7 is 3. So the answer is 3. The answer to this whole thing, it's just all arithmetic. There's nothing fancy about it. You're just doing arithmetic, so you're not solving anything. You don't solution set it. You circle it and say, yay, I'm done. And you get it out of the glare. 3. Okay. So f of g of 2. We start on the inside. Take 2. Plug it into the g function. See what you get. Take that answer, plug it into the f function, see what you get. Okay. I want you guys to try g of f of 2. Start with 2, plug it into the f function. I get 7. Yes or no?
Yes.
Okay. That's all. This is an introduction to composition of functions. Composition in this case means putting one function inside of another function. But we can be really weird, and there's a joke here, okay? Totally inappropriate. But what if I said, what is f of f, oops, of 3? This is where you can F yourself. Think about it. So again, start with 3. Put it into the f function. Get an answer. Put that answer into the f function again. Try it. Excuse me. Okay, so I get 33. So there's some confusion here. How do we say it? We start on the outside and work in. F of 3. Okay. How do we actually do it? We start from the inside and work out. Take 3 and plug it into F. Get an answer. Okay. And then take that answer and plug it into the other one, the F again, in this case. So how we say it and how we do it are totally backwards. Okay. Now it gets worse. Since it gets worse, does anybody have a question before I get worse? Okay. Then what would happen? I need to erase this. Does anybody want anything up here? You want me to wait a minute while you're copying this down? Are you okay? All right. These were all nice because I was only plugging in numbers. What if I ask you to find F of G of A? Uh-oh, I'm going to do it for you. I'm going to show you how. No numbers. Holy crap. So what's the first thing I do? I take A and plug it into G. Well, how do I do that? G of A would become A minus 4. Plug G or A into G in place of the X. Okay, that means this becomes F of A minus 4, whatever that mess was. So what did I do first? Took A, plugged it into G. Took A, plugged it into G. A minus 4. Okay, now what am I going to do? I'm going to take A minus 4 and I'm going to plug it into F. Well, where's the only thing I can do? Take that. That's going to become 2 times A minus 4, because that's what I'm plugging in, plus 7. I'm plugging this in place of the X. In place of the X, I'm plugging in A minus 4. So clean it up. 2A minus 8 plus 7. Final answer, it becomes 2A. Oops, I don't want red. 2A minus 1. That's just your answer. Bizarre. The reason it's bizarre is because I didn't plug in any numbers. I plugged in a letter. So you have to do your algebra with letters now. Okay. I want you to try G of F of A. Remember, I say it from outside in, but you work it out from inside out. G of F of A. Start by taking A, plug it into F, and see how you do. Okay, so this says start on the inside. Take A, plug it into F. Well, the only thing I can do is say this is 2A plus 7. Because remember, I'm plugging A in place of X. That's what, when we say plug into the function, that's what it means. A in place of X. Okay, I did. There's nothing more I can do there. So now what's that do for me? This problem now is G of that mess. Well, how do I G something? G says, whatever you give me, I'm going to take it and subtract 4. That's how you G something according to these rules. Okay, they'll be different on mom, they'll be different everywhere, but according to these rules, okay, I want to G this. Okay, so G says, whatever you give me, I'm going to subtract 4. Whatever you give me, X is whatever you give me, I'm going to take away 4. So that becomes 2A plus 3, and that's my final answer. But wait, there's more. Aha. Okay. Remember, mathematicians are just, I'm being recorded, I can't say that, effing lazy, hence the F of X. Okay, it apparently is too much trouble for them to write parentheses. So math has invented a special symbol. It's a little circle. It means composed with. Math has invented a stupid little circle, and we write it F circle G. Now, depending on the math instructor you pick up, the proper way to say this is F composed with G. Some instructors, okay, will just say F circle G. F circle G. The proper terminology is to say F composed with G. Okay. But I would say it's a 50-50 split in the math world. Okay. Some people say it the proper way. Some people say it just circle G, F circle G. I don't care. Okay. Doesn't matter to me what you use. However, F circle G is just a fancy way of saying F of G of X. That's all this means. F circle G means take the entire G function, all of it, and stick it into X, or F in this case. Well, let's see what that would look like. F circle G means F of G of X. Well, this is F of X minus 4, because G of X is equal to X minus 4. They're worth the same. G of X is worth X minus 4. Okay, well, how do you F it? What's the F function say? In this case, to F it means we go, whatever you give me, I'm gonna multiply it by 2 and add 7. That's what this f function says. So I'm gonna take it, multiply that whole mess, 2 times the whole mess, add 7. Clean it up. Minus 8, come on, dummy, plus 7. So there's your answer, is 2x minus 1. F circle G became 2x minus 1. Again, you're just doing algebra arithmetic. You're not solving anything, so just circle the stupid thing. F circle G. This is something you do need to know. When I give you F circle G or F composed with G, you're going to want to rewrite it in more standard notation. Remember, I told you, mathematicians are lazy. They invented this circle notation, and it means exactly the same as this notation. They just didn't want to write the parentheses and the X. So they didn't. So they got stupid, okay? But you start on the inside, take X and put it into G. Well, that's exactly what that says. Take that answer and put that whole answer, the whole thing, into the F function, whatever it says to do. All right, so I want you to find G circle F. Take a second to find G circle F. Okay, so G circle F or G composed with F is just a fancy way of saying G of F of X. These two are synonymous. They mean the same thing. Okay, so what's it do? We start at the center. It says take X and put it into F. Well, that is F. So that becomes G of 2x plus 7. Okay, again, look at this. F of X is the same as 2x plus 7. So you can throw that out and put that in its place because this says they're the same. All right, now how do you G something? What's it say to G something? It says whatever you give me, I'm going to take it and subtract 4. So when I want to G this, I take it and subtract 4. Final answer, 2x plus 3. Okay, I have one more topic I want to talk about tonight. We'll review these tomorrow and we'll extend our knowledge of chapter 10. But this is all in 10.1. And I want to make sure that we get through 10.1 tonight. We will review this and extend it to 10.2 and 10.3 and whatever we get tomorrow night. So this is called function composition. It's where you put a function inside another function. Now we can get really weird. We've only been dealing with 2 functions. What if there was a third function? What if there was an h of x equals 5x over x plus 2? Then I could say, okay, what is g of h of f of 3? I mean, we can get really weird. And you'd have to take 3 and put it into f. Whoops. And take that answer and put it into h. And take that answer and put it into g. Okay, so we get weird, but we're only sticking with 2 functions at a time. That's all I will test you on, just 2 functions. But I will use this notation, F circle G or G circle F, or I may use the parentheses notation. You need to be prepared for both of those. All right, last topic. Try to keep it short so we get out of here a little bit. Anybody following the World Series? What's up? Okay, nothing. All right. Now, little bit of theory. This is called inverses. And I'm going to give you a little bit of theory and then we'll expand upon it tomorrow night a little bit. Everything in math has something that undoes it. For example, if we had X and we added 3 to it, if we take away 3, we get back X. So we've learned that addition and subtraction are called the inverse operations of each other. They undo what the first one did. If you took a number and added 3 and then take away 3, okay, you're back to your original number. Okay, we've also learned that 5 times X divided by 5 gives back X. So we've learned that multiplication and division are called inverses of each other. They cancel each other out. 5 times X changes it, but divide by 5 changes it back to the original X. We've learned that the square root of X squared gives back X. So we've learned that squaring changes the X, but square rooting changes it back with some limitations. You know, there's this plus and minus and all this odd even crud, but basically that's the idea. We've learned that squaring and square rooting change each other or cancel each other out. And there's more, but this is the basic idea. Mathematicians want everything that changes X to be reversible. Change it back. Can I change it back? And when we find those, we call that the inverse. The inverse of each other. Addition, subtraction are inverse of each other. Multiplication, division are inverses of each other. Square rooting and squaring are inverses. So I want to find the inverse of a random function. Okay. I'm going to give you the rules, work through a couple examples, and then say goodnight. First, replace f of x with y. That'll make sense in a minute. Second, swap x with y. Okay, trust me. Third, solve for the new y. And fourth, replace y with, okay, hold on to your shorts. Okay, new math notation. We have learned that when you put a -1, it means the reciprocal. Flip it over. Except when you put it on a function. When you put the -1 power on a function, it means something totally different. It means this is the inverse of the original f of x. It's a way of telling the world, this isn't just any stupid old function. This is a special function. This is the inverse of f of x. These two cancel each other out, just like addition and subtraction do. Well, let me go through the steps for one or two examples, and then we'll call it a night. Find the inverse of, okay, number one. Suppose f of x was 2x plus 7. Okay. Replace the f of x with y. Y equals 2x plus 7. Swap x with y. X equals 2y plus 7. Solve for the new y. Remember, that's a phrasing we use in algebra. Solve for y means get y alone. Okay, so how do I get y alone? Well, we subtract 7. Then we divide by 2. And then it says, replace the y with the f inverse of x. Remember, this is a new notation. On a function, the -1 power means the inverse. So we would say x minus 7 over 2 equals f inverse of x. And I am going to be a stickler for this. Okay? Because what you're telling me, what you're saying here is in our original discussion of a function, f of x, this f of x changes a number. For example, if I said find f of 7, you'd say, oh, that's 2 times 7 plus 7. That's 21. 2 times 7 is 14 plus 21. So f changed 7 into 21. F inverse will take 21, plug it back in. Okay, plug it back in. F inverse of x, plug it for x. 21 take away 7 is 14 over 2, changes it back to 7. So if f function takes 7 and turns it into 21, f inverse takes 21 and mathematically changes it back to 7. So these two functions are the inverses of each other. They're not just some function I just made up randomly, like I do up here a lot. They're the inverses of each other. They cancel each other out. Whatever f did to change a number, f inverse changes it back to its original. All right, enough. We'll go over this in more detail tomorrow. Hasta bye-bye, guys. Have a good night.